extra with the stuff that needs to be written in a moment. So again, don't write on this mat except to put your name at the top, because you're going to use it over and over. So if you'll just put your name at the top, so you know it's your mat. And if you will get your bag out, you'll get your bag back out that has your algebra tiles in it. And if you'll pull out, again, the ones that you already know what are, and that's only one kind. Because there's 3 shapes in there, right? There are 3 different shapes of tiles. The only one we know about right now is the little squares. And the little squares are all, you're taking this, right? For me, that's on, right? For the absent kids, okay. So, these tiles, the small ones, represent what and what. So there are several things that can be said about these tiles. Let me say the question again. These tiles represent what? There's several representations of these tiles. These. Lincoln, give me one.
Well, like the yellow part of the tile, that's +1.
Okay, +1 if it's on the yellow side or tan side. Something else about the tiles. Jayla. On the red side, Josie, pick one over to the red side. The red side represents -1. Betty, what else can be said besides those 2 things? More things can be said. There you go. I didn't know if anybody would come up with that without me saying it. They represent an integer. Okay, table 3. Eyes up here, please. They represent an integer. Angelo, what's an integer? Perfect. He said it exactly perfectly. It is a whole number, all the opposites of all the whole numbers, and 0. It does not include fractions or decimals. And there's one other thing I can say about these little squares. They are the what's in the problem. Think about terms. Somebody I have not heard from Permita.
The constant.
The constant. They are constants, right? Because that 1 is always going to be a 1, or 2, or 5. There's no other thing that's ever going to be in any other situation, right? So if you will move your pieces over here and flip the paper over. All right? So we're going to model a couple of problems. So the first thing we want to model is x plus 2 equals 3. So to do that, Josie is going to place this right here. Okay, so this represents what? What is that? Somebody who I've not talked to. James.
The equal sign?
Well, see, you're playing with your tiles and not paying attention, right? And I just happened to coincidentally look up and your name was on a highlight. So I'm talking about, I shouldn't have to repeat myself, what does that represent?
The 2 big squares.
Huh? And the equal sign in the middle.
It represents the 2 sides of the problem.
This is a representation of a balanced set known as an equation. Correct? All right. We're going to introduce another tile right now, and that is the tile that is a rectangle. So get 2 of the rectangles out and get 1 of the big squares out. Get the rectangles out, but get 1 big square out. We're only going to tell you what the big square is right now, but we're not going to use it yet because we're not there. And you have to know about the rectangle before you can know about the big square. All right, so Josie, will you please place a rectangle on one side of the equal sign? All right? That represents your variable, your x. That represents your x. You didn't drop it. You didn't drop it. Yeah. All right. This represents a variable like x. Okay? That's what that represents. Now, I'm doing two things at once here. Will you, Josie, on the other side, put two positives side by side? Okay, make side by side where they touch. Okay? Now, if I wanted to know the area of a 2 by 2, that means it's 2 this way and 2 that way, right? Area. Will you set that up, Josie? 2 by 2 is 4, right? Agree? All right. Do you all see there's 4? Okay. Watch my pointer. Okay. Would you agree this is an area of 4? If she studed that one in this class. Would you all agree? Would you also agree it is 2 length by 2 width? Alright? Will you please show me the 2 by 2 that made up that 4? Josie. Will you show me the 2 by 2 that made up that 4? Now leave those together. Now take 2 more on the out and put right here. Times 2 right there. I know you're like, I don't get it. So lay 2 more tiles right here. And then lay 2 tiles right there. And where you fill in the square, that's your answer. So now, Josie, if you will pull the 4 out, the 4 in the original 4, okay, that's your 2 by 2, right? So look what I'm saying. It was 2 wide times 2 long, and it had a square it made of 4. Because literally, area makes a literal square, right? The idea of square. Okay, you're going, where are you going with that? I'm explaining the big square, the big one. Okay, the big algebra tile is x squared. The big tile is x squared. So, Josie, will you lay one of the big tiles up on there? And will you show me how that's x squared? Do you know how that's x squared? So one rectangle is an x, right? And so an x times an x, right, makes the big square. So lay one of the rectangles here and one there. That's what the big square represents. So Josie, lay one along the side here and along the top. So that big square is x squared. Because it's saying it's got an area of x times x. Because I just showed you that 2 times 2 is 4, right? Isn't, guys, 2 squared equal 4? Well, x squared is that. So we're not going to do anything with that yet, but that's what it is, okay? So if you'll put the big squares back in the bag. And only about half of you were fully in on that, because some of you were playing. And see, here's what's going to happen. Tomorrow you have to create a video explaining how to solve problems with these, and I'm teaching you how to use them right now, so you really want to listen. I'm showing you how to use them to play the game. So, the 2 tiles we're going to use are only going to be the x's, called the variables, and the constants, called the numbers. Right? Or numbers called the constants. Those are the only two we're going to use. All right. On here, whatever's here has to equal here. Agree? Whatever's here has to be the same as here. I need you to show me x plus 2 equals 3 on your mat. X plus 2 equals 3 on your mat. And Josie's going to put it up on there. X plus 2 equals 3. We all know that x is worth a 1, isn't it? So on your mat, you're going to have an x and 2. And over here, you're going to have 3. Question. How do I isolate the variable? There are two things I have to do when solving an equation. What are they, Madeline? I isolate the variable and keep the balance. Okay? Here's my literal balance scale. Here's Dolly. Here are 2 kids. Here are 3 kids. If I take 2 kids off both sides, right, then Dolly will be isolated. So now, let me ask you this question. No, you can't just pull them off. Okay? Not yet. Now, she's like, I can just pull them off. Okay? I shouldn't say that. I should have said don't pull them off yet. Okay? So there are 2 ways that can happen. There are 2 things that can happen right here. I can subtract 2 from both sides by takeaway, right? Okay, so now, Josie, literally take away 2 from both sides. Was that a legal move? It was a legal move because the scale stayed balanced, right? Now it tells you if the scale is balanced, this thing weighs the same as that thing. So that x was literally equal to 1. Now, do not get caught up in the fact they're a different shape, right? That's fine. Think of it like this. These are envelopes with mystery money in them. These are all literally dollars. Every time. These are always $1 or negative ones. These are always mystery envelopes that have positive or negative amounts in them, right? Okay? Now, let me show you, put those back on. Let me show you the other way. The added inverse, and we said that earlier, the added inverse version would be to do what to both sides? Make 0 pairs out of those? What would you literally do, though, on your paper? What would you literally do on your paper?
So, you would make 0 pairs and take the negative and multiply the positive.
So if I literally put, that's right, if I put 2 negatives on both sides, would that keep the scale balanced? If I put 2 negatives on both sides right now, with the balance, okay, put those on there. If I put 2 negatives here and 2 negatives there, did my balance of my scale shift? No, it did not. It did not shift. Now, here's the thing. It didn't shift because those don't equal anything, because plus 1 minus 1 is a net of nothing. Plus 1 minus 1, nothing changed. But even if I added on 7 ones over here and 7 ones over here, would my scale still be balanced? Mm-hmm. Yeah, but I wouldn't have that doesn't help me figure out what that's worth. So I want to do only moves that will help me to isolate the variable by itself, but not upset the balance of the equation. Keep it balanced to both sides. Ashley, you paying attention? All right, so those 0 pairs go away because they're worth no change. And again, pull the 0 pairs off. And you're still left with x is worth 1, right? All right, so will you on your mat put the problem back up as it was. It was x plus 2 equals 3. Okay? And will you please take a picture of that with your device? And Josie, you can just take a picture from there. You want to grab your device? If you'll take a picture, and an overhead shot, straight down shot would be better than a slanted one, because you get it out of proportion. And will you please pull in your markup tool? And will you write in the box what the equation is, what the answer is, and how it will be done with your work? So here's what I'm wanting you to do. Okay? If you'll write in x plus 2 equals 3, x equals 1, show the step here, and will you show up here what you would circle these and draw them arrowing off, right? And then if you'll text me your marked up photo. Miss Clemens, you okay if we finish about 5 more minutes?
Good until fifth grade's third block.
Oh, so we're good. Okay. Now, one of the things you're going to do tomorrow on your Flipgrid video is you're going to be dealing with the statement, Mr. P is a dummy. And you're going to have to explain this to him. So you cannot assume anything or assume that he knows anything. You have to show exactly what the model says about solving the problem. That's what we're practicing right now. We're doing it together because you're going to do it by yourself then. So again, mark it up with your finger or your Apple Pencil. And then Josie is going to set up the next one. We're going to do one more. And Josie, the one you're going to do right now, we're not going to do that third one until tomorrow because we have to deal with like terms. We're going to practice that tomorrow. So Josie, if you will set up the next one of 2 x's plus 4 negatives, and that balances with 8 positives. We're going to do that one as a pair. You're going to do that with your elbow partner. And then I'm going to match up people that don't have an elbow partner in just a second. All right. So if you've not, okay, so let me do, I'm having you to juggle 2 things right here. So send me that picture of number 1 and go ahead and set up number 2 like this. Now for number 2, only one of you is going to have to send it to me, so you're going to do number 2 together. So the first one you sent alone. This one you're going to send as a pair. Here's why. That one you're doing right there, 1 step involved. There's only 1 operation. This one is a grandma. Anybody know why I'm calling it a grandma? Why? Anybody know why I'm calling this one a grandma?
Oh, because
Slow.
like the letter.
Because of the letter. Because of the letter. What is it the letter is reminding us? There's a variable. What does the letter remind us? Yep.
To go in reverse order of operation.
Uh-huh. When you're undoing everything, you undo it in reverse order because that's literally what Grandma does when she reads your letter. Or vice versa. So, before I move any further, I need your eyes. I need to give you another rendition of Grandma's letter.
Oh no.
Oh, yes.
Oh no.
So look up here. So I go to the mailbox and I pull it out. I'm like, oh! By the way, as a kid, every time there was a new bar of soap, the soap usually had a little thing that pulled up, and I was go, ooh, it's a letter. And I would open it like it was a letter, the soap. Okay, so, oh, a letter from Grandma. So I'm going to undo the last thing Grandma did, which was seal the envelope. I'm unsealing it first. Did I not make myself clear? I'm not looking up here. All right, I'm unsealing it. Izzy. I don't care. I told you to look up here, right? Yes or no? That's a little much. You cut your eyes around me like I was disturbing you. Unsealed the letter, right? Okay? That was the last thing Grandma did. What was the next to the last thing Grandma did, Izzy? She stuffed the letter in. So the second thing I'm going to do is unstuff the letter. That was her next to the last thing. That's my second thing. What's my third thing is to unfold the letter. And what was her second thing to do? Fold the letter, right? And then the first thing she did was she wrote it, and the last thing I'm doing is reading it, right? So everything has to be undone in reverse order. Now, the question is, why am I bringing this up right now? Because up on the screen is a two-stepper. It's a granny, right? You're like, I see one sign. It says 2x minus 4. It's minus. Is that right? Kylie?
The 2x means multiply.
There's a multiply and a subtract. Hey, James, was I not clear about what I asked you to do? Yes? Okay, thank you. So yeah, there are two steps. There's a multiply step. There's a subtract step. So if I'm doing order of operations, which one goes first? Multiply. And then I would subtract last. Well, if I'm undoing it, what am I undoing first? The multiply or the subtract? The last thing gets undone first. So undo of minus is plus. So, Josie, Izzy's going to tell you what do I need to do to undo minus 4. What does she need to do to undo that minus 4? Both sides. So, how can I do that? So, if I take this and this away, is that balanced? Anybody disagree? Why? They're not the same things. Right. So, that would work if they were positives, but they're not. So, but I still got to take 4 negatives off, right? What can I do to be able to take 4 negatives off?
So you just take 4 negatives because it on the other side, so it wouldn't.
Okay, let's move on. You have no reason to know this yet. I want to push you to see if you can come up with it. What we know is I have to get rid of this. Look, guys. This has to go away so Dolly is isolated. This has to leave, but it has to leave legally by keeping a balance. I can't take 4 of these because there's not 4 over here. How can I make that happen? I have to get those off, but I have to do it on both sides. How? How's that going to happen? How's that? Okay, I see hands on every table almost that think they know. Okay, I'm just going to keep your hand up. Just tell me quickly what you think I need to do. And if they say the same thing, go say it again. Say, lock in what you're going to say right now. Cows are brown. Okay? Cows are whatever. Whatever the words are you're going to say, keep them and say them regardless if they've been said. Betty.
So you add.
So quick, come on.
You add 4 positives to the word negative and 4 negatives to the positive.
You take away the 4 and add 4 positives.
Okay, is your hand up? You sure? I think it was. Come on, Ron, tell us. say it anyway. That's fine. You took a risk. Try.
Add 4 positives to each side.
Go ahead.
Flip over the 4 on the left and then put them on the right.
Okay, Nathaniel.
Add 4 positives to both sides.
Okay, James.
Take the 4 negatives and make them positives on the other side.
Okay, Melis.
Add 4 positives to each side.
Okay, Kylie.
I was going to say add 4 positives to both and you can make it even.
Okay, yes.
Add 4 positives to each.
Okay, Lincoln. All right, Fallon, stand up, please. So you remember a minute ago when you put your hand down, you're like, but I think I'm wrong. And I said, say it anyway, take a risk. You said exactly the correct answer. As did Nathaniel, stand up. As did James, stand up. As did Kylie, stand up. And I think maybe somebody else I lost count of. All right? Okay, yeah, Jayla, yeah. Okay, thank you. That's exactly correct. Now, Fallon, go up there and do that, and Josie, step back. But you got you're minding the store, so stay up there. So, thank you. Have a seat. Now, Fallon, do that. Okay, go take some kiwis.
What?
This is mine now.
He cleared his math. Not even, she just won. No, it's swipe. Now, back to the 2 rules I have been beating in for weeks. You have to isolate the variable legally by keeping a balance. Now, can I now do anything? What? She put 4 pauses on both sides. Okay, so question. If I put 4 here and 4 here, was that a legal move? But she didn't isolate the variable. Let's see if it's yes, I did. Oh, you did, Fallon. How did you do that?
Did you?
The positives on the left take away positives add up to 0 and that's nothing.
0 identity. Identity 0. Look. That's 0. That's 0. That's 0. That's 0. That's worth nothing now. They cancel out. So if I put 4 on both sides, it cancels out those negative 4 because I need them over here. Now, a couple of you said I need to move those over there. But the thing is, that wouldn't be a legal move because when you were doing that, your scale went like that. But if I go at the exact, remember at camp when we stepped on the thing at the same time?
Oh, yeah.
If I were to do that at the same time, those are canceled out, but it was a legal move. Right? Because as I was putting a new one on both sides, that was becoming 0 and another one. So now it's still balanced. All right, now move all those off because they're 0. Because I can put 0 pairs on or off. Remember, 0 pairs can hop on and off anytime they want because they don't upset the balance because they don't weigh, right? Okay? So 0 pairs can jump on and off, on and off, on and off, on and off. They're good. Now, thank you, Fallon. We did one of Grandma's steps in reverse. She had -4. We added 4 to both sides. Because isn't that what you do with the algorithm? You add 4 to both sides. Isolate. Now, Mason, how do I finish the work? This is the last thing I want to show you because this is one more move that you don't yet know. I got to do one more thing. You're like, well, it's 2 x's equal a bunch. But I need to know what 1x is worth, right? So now I'm down to 2x equals 2, 4, 6, 8, 10, 12. Everybody in here knows x is 6.
Yeah.
All right, Mason, go up there And will you arrange stuff in any such a way that can show me that x is worth 6? Arrange the things so the rest of you be thinking how that's going to look on yours and see if you can beat him getting it done. Now, wait, whoa. Nothing can leave the mat. Nothing can get off. But how can he rearrange it to show you what everything's worth? How can you rearrange it? I'm going to stand up here. Okay.
You're nobody.
You actually matter the most of
This is
How do you make the heart?
This is so sad.
It will
Go
burn.
get your
All of
picture.
it.
What are we talking
Exactly.
Alright. Okay. Did Mason show you that x is 6? Yes, he did. That is how you would model a two-step equation. So we took and dealt with -4. We kept a balance. And then we dealt with 2x by dividing 2x by 2. Well, if I divide 2x by 2, I divide the 12 by 2. So every x is worth 6. Every x is worth 6. All right, thank you, Mason. And he actually was doing that. I went up there to tell him, he said, well, that's what I was going to do. So he got it. All right. So, really quickly, if you will recreate, so let's pretend like you're doing a stop motion video, and you've got a video, you got to take some pictures of the pieces. So pretend in your mind like you're doing a stop motion video. Show me the original problem, the first step, and the second step. Take a picture of each one of those because you're going to need them for your flip grid tomorrow. No. Take a picture as if you're making a stop motion video. Later, if you want. Okay, do what I said right now. Add to. Quickly take your photos because you're going to need them tomorrow. Yes. Here's the thing. Every algorithm, there are alternate algorithms. Yep. And you already know that, but most people don't. Yes. The original problems are the second problem on the TV. 2x minus 4 equals 8. Okay, borrow. Hey, if you don't have enough of something, just borrow from the person beside you, and then give them back, like Fallon did. Of course it does. That's negative. That's positive. Fallon said, does it matter if you've got the red side up or the green side? Yeah. The two x's are green because they're positive x's.
So we're just supposed to take 3 pictures. Can we just take 3 pictures?
So I want you to ask that question later. Not today. Remember that question. That is so I will just say, Kiwi's going to remind you later that if the x is red, what does that mean? So when we get there, he's going to tell you what that means. Because he just figured it out, so he's going to be the person who will announce that tomorrow. We're not doing that today. So once you've taken your photos you're going to need for your flip grid tomorrow, will you please put all of them back into the little baggie? Remember, you've had them for years. Please don't be the person who loses the pieces. Put them all back in the little baggie. I'm going to give you 3 more minutes to be done. You have 3 minutes to be finished. 3 minutes. Jalen, will you set the timer?
Okay, I'm about to get done.
Hey, Miss. Yeah, we need to answer my own question.
Okay. I'm done.
Yes. 3 minutes. Once you have put them back in the baggie, will you please get out your reading section from the social studies book? All right, 2 minutes. I need you to have your math put away. I need your social studies book out and your notes. And your wheel, of course.
We have to get our wheel back out.
All right, 1.5 minutes. Come on, get them up. If you are not finished, you're going to have to stop anyway, and you'll have to finish later. If you did not get your pictures taken, I need to put them up, please. Kayla, you're putting them up. Liam, James, Fred, grab your phone. Hey, Dave, now, come on. Will you hit pause? Stop. Start again with another video.